is going to move us into a couple of different features. Let's do a quick revisit of what we do with a cube. So here's a cube. And here's the inside, just like what we were just practicing in our warm-up. Okay, so now you'll notice one of the things that happens in here's a little bit of classical perspective. In classical perspective, there's an object called a horizon line, and the horizon line represents the eye level of the viewer. Okay. Here's my little viewer. And if you have an object that's like directly in front of you, that object, a rectangular object that's directly in front of you, that object will be in 1-point perspective. So that's like the classical train tracks. And so if you have a single point and you connect out like this, right? And the lines that cross this way, as they go back in space, get closer together. So they get shorter and they get closer together. Now, these lines represent parallel lines, but based on the way our eyes work, based on the fact that we have two eyes and the shape of the lens, the lines appear to converge in space. They appear to get smaller and closer together as they go away from you. A cube, now in 2-point perspective, so the 1-point perspective represents a viewer who's standing right here, okay, looking directly at an object. That's how you have 1-point perspective. Now, if this viewer is looking at an object that's over here, this is where you have 2-point perspective. And what happens in 2-point perspective is the lines converge. The lines of all of the sides also converge to vanishing points on the horizon line. So here's the horizon line. Here's the horizon line. And the lines converge to these points on the horizon line. Okay. Now, okay, so this is 1-point perspective. This is 2-point perspective. So we have two separate systems here, okay? In both systems, the rule that we're using is that as things go back in space, they get smaller. So here's our person further back in space. Actually, their head would still be at the horizon line, but they're further back in space in here. They're further back in space. And as they go further back in space, as things go further back in space, they get smaller. Okay, so this is really the kind of technical way of referring to it as a law of convergence. So what happens is parallel lines, as they recede in space, so here's parallel lines, right? As they recede in space, I'm going to turn this into a cube. As they recede in space, they converge. And they will eventually meet at the point called the horizon line. Okay, so this line, and over here would be another, if I put a point here, okay, so this is important information. And what happens is when you're looking at a cube, if the cube is at eye level, you're going to be seeing two planes. If the cube is below eye level, you're going to be seeing three planes. So here you're seeing 1, 2, 3 planes. And when you're drawing a cube, you want to take advantage of this convergence. So really, it's always essentially 3 sets of parallel lines. It's these lines, and then these lines, right? And they'll always be, it's 3 sets of lines, all of which will converge. You don't have to have the vertical lines converge, but if you just go like this, okay, and so you've got converging, 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 converging. Now I'm in a little bit of a tricky spot because I need to have the third line here converge, and I need to have the third line here converge, right? And that's the place where the most mistakes are made with that third line, okay? So that's just like a quick tour back through some important points in perspective. Okay, so here we are with a cube, and I wanted to start to introduce some other properties of the cube. So for instance, the way that we find the center. So I can go from corner to corner, and from corner to corner, and that gives me a center point. And that works on every single plane on the cube. So for instance, I can go from corner to corner here, and I can go from corner to corner here, and that gives me another center point on the cube. And now I can put a line through the center of those, okay? And this takes us to the next part of what this lesson is about. Okay, so here's what we're about to get up to. So you have a cube, managing my convergences. You can see where my mistake is here. Okay. And so what we're going to start to do is we're going to start to take this cube as a basic manipulative. Like we're going to take it like a chunk of clay. Imagine this thing as a chunk of clay, and I can start to do stuff like this with it. I can start to say, well, I want to take this chunk, I want to take a chunk of it out. I can just make some cross contour lines, right? And I could remove a piece. And it starts to make fun and interesting shapes. So I could take a piece here and I could remove it. And I could take a piece here and I could remove it. And here's a piece I'm going to remove. And it starts looking like a piece of modern architecture, like something out of Dubai. Okay? Okay, so let's do that again. Here's a cube. Now let's start some removals. This time I want to work from centers. Here's my center. I like to put a dot and an arrow and then find the place where those two are like guns pointing, and where does the bullet pass, and that gives me the middle. From there I can go upwards. I can do the same thing on this surface. Arrow, arrow in the middle. Okay, arrow, arrow in the middle. That's the middle of this. Where this and that hit. Okay. Kind of a stair. Okay. I can find the center of this little space. Center. Arrow. Center. Using the law of convergence between here, here, and there, I can surmise where the line would be, where the center line would be. I can go like this too, just for fun. So this is subtraction. And it works with every shape we know. So let's say, for instance, we were going to start with a pyramid. Here's my center. Here's my center. Lift the line out from the center. And it helps to be skillful with showing the lines that are on the inside and the lines that are on the outside. So for instance, here's a line on the inside, and I'm going to go really light with it. And I find that that helps a lot. And now the pyramid I can start subtracting from. I could subtract, I think I'll start by doing this. Just cutting a chunk off the top of it. Makes a really interesting shape. Same with the cone. Starts with an ellipse, minor axis, major axis, I think I'll do this one as a cylinder. Here would be and I can take a piece of this, say I could go working with the major axis, which I've messed up. Say I put another ellipse in here, I could decide that I want to remove this whole chunk of it. Okay. Go on to the cone. I want to do something interesting here. I want to take out a wedge. Finding spots on the outside of the cone. Okay, so yesterday what you were working on yesterday's lesson, you were working on something that we would call addition. This is subtraction. So addition, you were able to do this. Take a shape, and add another shape to it. And now with subtraction, we're also able to take shapes away from it. And it starts to make our shapes that much more interesting. So it starts out as a really basic cube, ends up with all kinds of interesting possibilities. Kind of looks like a little space station type thing. Okay,